Okay, we've done question 7a and we've shown our proof. Now we're going to have to use it. 7b very definitely says hence at the start of it. Hence solve this equation. Right, and have a look again. So remember with a hence we must be using something we've already done. So what's the same and what's different? Well, apart from the fact this says 2 theta and this says x, it's pretty much the same. So that means that we can use the identity from part 1. So in part 1, we had tan squared x equals 3 over 2. What's changed in part B is instead of x, you've got 2 theta. So tan squared 2 theta must be 3 over 2. And we've just got to solve this. Now in order to do that, you don't need to write this step, but you need to remember that tan squared 2 theta means tan 2 theta all squared. Now that means in terms of order of operations, the first thing I do is square root both sides of my equation. And I have to remember that when I square root, it could be positive or negative square root 3 over 2. That means I've got two equations to solve. I've got tan 2 theta equals positive 3 over 2, square rooted, and tan 2 theta equals the negative square root of 3 over 2. Right, this is where we need our calculator. So checking the question. The question's in degrees, so I make sure I've got a D at the top of my calculator to say it's in degrees. Then I'm going to do inverse tan, get my order right, of the square root of 3 over 2. And that tells me it's 50.768 and stuff. So I'm going to keep some accuracy here. So from this one, you can do it in a table, you can do it in the line. I've got 2 theta is 50.768. And then from the other equation, I do the same thing again with, there we go, negative. That tells me the answer is negative 50.768 degrees. Okay, and now we've done that, let's check what the interval is. So it's going from 0 to 180. Now, the calculator only gives us the first solution. We need to remember to find the second solution. So if you remember a tan graph, the way to get more solutions is just to add 180 degrees. So, all I need to do now is take my answer, go back to my previous one, and I'm going to add on 180 degrees. It's going to give me 230.768. You could, if you want to check, we could just add on there we go. If you add on another 180 degrees, you're going to get 410.768. Just add 180. Now, I haven't quite finished the question. You're going to see why I've stopped there in a second. That was what 2 theta is, so I need theta. So now I'm going to divide my answers by 2. So I've got 50.768. You could have done this earlier to keep it accurate. Divided by 2 gives me 25.38 degrees. If I take my 230 and divide that by 2, I've got 115.38 degrees. Now what would happen if I divided 410 by 2? Well, when we get to 200 and something, that would be too high, it would be above the range. Now you could work that out to start with, but I don't actually want that solution. Now let's try again with the minus 50. So negative 50.768. I'm going to add 180 onto that. That gives me 129.232, and then add on another 180. Oh, take the answer, add on another 180. We get 309.232. If you divide that by 2, it's still going to be in range. If you added on another 180, you get 489. If you divide that by 2, it's going to be too large. So we've got enough solutions in this one. I just noticed a little negative was snuck in there. Right, if you divide 50 by negative 50 by 2, you can get a negative number. So we don't want that one because that's below 0. Then we're going to take our other answers. So we take our 129, divide that by 2. We get 64.62 now, and then we're going to take 309 and divide that by 2, and I get 154.62. Now, every time I'm rounding, I'm losing accuracy, so that's why I started with 3 decimal places, because I make sure I keep enough accuracy to get my final answer to the nearest degree. So to the nearest degree, I've got 4 answers. They are 25 degrees, 115 degrees, 65 degrees, and 155 degrees.